Go.
Hello.
Hello, Mr. Ryan. How are you today?
Welcome to the Pokemon land.
Okay, so today,
Pokemon.
yeah, listen to me. Yeah. So given a binary tree, yeah, one, it doesn't matter what values we are putting in. Alright, let's just don't. We don't need to put the values. Yeah, the binary tree. What's the longest path? Remember we talked about the longest even path. Yeah, longest even.
Five.
Okay. So let's get rid of this even today. So we want to find out the longest path.
Six.
6?
Yeah.
Yeah.
One,
Okay, let's say
nothing. 2, 1, 2, 4, 4, 5. Is that the way?
Okay. So
Okay, number
I
like it.
yeah. So what's that?
6, 2, 1, 3, 4, 5.
6, 2, 1, 3, 4, 5. Yeah, that's the longest. Yes. Okay. So
Yes.
we talked about the longest even path. Yeah, last time. Yeah. And then can we use the same algorithm to solve this problem? Yeah? Obviously, if we don't check the even, if it's even, then it'll still work, right? So we can use the depth first search, right? Yeah. Do you still remember what depth first search? I mean, do we use? I mean, what kind of depth first search? I mean, how can we implement the depth first search? Okay, so let's review this. Recursion. What's the breadth first search, by the way? If we want to breadth first search.
1, 2, 3, 6, 4, 9.
Yeah, let's level by level. And then another way of doing this depth first search is 1, 2, 6, 3, 4, 5, 9. Okay? And then recursion we use the stacks.
3,
Okay?
4, 5, 9.
Okay. Okay, so let's say if we define this depth first search root, DFS search root. So what should it return? Can you tell me what should it return? Remember the last time?
Guaranteed.
Yeah, where's the? Can you find a pen? I'm running out of the pen. What's this
The
return?
pens
Yeah.
are up there.
Okay. So what's the return? What's the depth first search returning? I mean. Okay, Ryan, Eric. What's the depth first search root? What will you return?
It will return the routine.
You will return the what? So depth first search root. What if I said this depth first search root return the longest path? Okay, longest path.
1, 2,
Starting from this one.
1, 3, 4, 5.
So how many nodes are left?
4.
4. Okay. Yeah, that's good. And okay, so it returns that bit, right? So how about if I telling you that okay, so this bit here, if this bit here is depth first search root dot left, and let's say put it as L, and this bit is depth first search root dot right, and let's put it as R. Okay? Yeah? This is L bit. L bit will be 2. Right bit will be 3, right? So L will be 2 here. R will be 3. Okay? So what's the longest path? What's the longest path? So what's the longest path that passing through the root 1 here?
Longest path.
Passing through the root 1. What's the longest path?
6.
Yeah? How do we get a 6? How do we get a 6?
We just.
How do we get a 6? This bit is 2 plus 1 plus this bit 3. Okay? Make sense?
Yeah.
Yeah. Okay, so then we can write this, yeah? Look, depth first search root is the longest path that starting with this node, okay? Right, starting with node. So here it will be 4, right? And this bit is depth first search root on right. This bit is depth first search root on left, right? So the current path, the longest, the path that's passing through the root would be 1, yeah? We have one node, and the left bit, the right bit, right? Yeah? So this function, remember, this function does 2 things. First thing, it returns the longest path, starting with this root, right? And the second thing is that it needs to compute the longest path. Yeah, you store the maximum number of nodes that passing through that root. Okay, so that's 2 things. And then we can just write it. Okay, let me just write it here. depth of search that root, okay? If not root, return what? If not root, return what? Come on. 0, easy. And okay, left equals depth of search root of left. And what's next? Huh? Right equals what? Right equals what?
Right equals deficit root dot right.
Okay, root of right. Okay? And then however answer here, answer equals 0, okay? And then in order to access the answer, I need to put it at the long local answer. Okay, because this is inside a function. I want to say, okay, this answer here is the answer here. So I put a long local to. And then I need to do this answer equals maximum of answer. Can you complete this? So what's here? Look, what's the path? What's the number of nodes that passing through the root here?
Left and right and root.
And 1, okay. Left, right, and right. Okay, but now this function needs to return what? Return the longest. So look here, this is left bit. Here, this is right bit. And this function should return the longest path that's starting with this node. So it could be picking the maximum of both. Yeah. So what should you return? 1 plus what? The biggest one. So the maximum of what?
Left and right.
Left or right. Okay. Yeah. So for this one, the time complexity is what? If there are n nodes. Don't do that. Look, if there are n nodes, what's the time complexity? Oh, and the number of nodes that visited, because we visited each node exactly once. Okay. Yeah. So look, quite similar. Yeah. Last time, what did we did? What did we did? Before last time we need to check. If the root is even, then we need to do this. Otherwise, if it's odd number, then return what? 0, because it's odd number, right? But now we just get rid of if here, right? So everything will be the same. The depth of search, you see? Yeah, the longest path. Okay, so that will be it today. So today, actually, this is not new. Yeah, this is something that we know how to solve before, right? So we just get rid of that condition, even path, right? And then this way we can check. We can compute the longest path between any two nodes. Right? Yeah. Okay, that's it today. Bye bye.
Bye.